gentlemen. I'm going to be talking about creating water-sensitive cities. What Sanjay talked about is a nice segue into what I'm going to be leading into. I have a mentor, his name's Roberto. He has been working in the field of water for the last 40 years. He's written a lot many books, has researched water on a molecular level, and he's come up with this remarkable statement. Initially, I could not believe that really character of a nation could be determined by the quality of water. And he formed the linkages for me. It really goes deep down to what is our relationship with water. Typically, we just treat it as a commodity. It's much more than that. It's life, it's energy, it's a building block. It is who we are, more than 70%. I mean, you all are a very informed audience. We're more than 70% of the planet, more than 70% of our body consumed. So clearly, what we see around, if we see our water bodies as on the right-hand side, unfortunately that's the case in India, guess what? That's the nation we're building. So this is really a nation-building exercise. It's not just about water or a natural resource. I think this has already been addressed. There are plenty of risks by not managing the fresh water available to us. My presentation flow would be, I just want to spend, since my time has been cut short by our respected chairman, I'll just spend a little bit of time on why we do what we do, what's the vision that inspires us every day. We'll talk about the tools for water-sensitive urban design and technologies. We'll give you some case studies. What's wrong with this picture? This is how we look at our cities. This is how most of our urban locations are. You go from New York to Boston to Delhi, anywhere. This is roughly the picture that we get. Yeah, we can add a little bit of green here and there, but this is a serious problem. This is a fundamental design problem. And unless we address the design problem, we'll always be thinking downstream. We'll be treating wastewater. We'll be doing water audits. We'll be doing all that. Fundamentally, a leader has to be a designer. A designer has to be a leader. Period. Unless we start thinking upstream and create technologies which solve problems at the source rather than later. It's prevention versus cure. We continue to see proliferation of disease, proliferation of these problems. So this traditional solution causes almost a pollution, destroys natural ecosystems, pollutes water bodies, pollutes air, blah blah. If the list is endless. There is an alternative. There is an alternative by creating water-sensitive cities. I mean, water-sensitive cities is one word. Let's just really think about it. It's sensitive. Sensitive to our environment, sensitive to our nature, humane. We can create a sustainable solution. I call it responsible luxury. We don't have to live in any kind of poverty, or we don't have to deal with things like conserving. We can actually live in responsible luxury. We just have to know how nature functions and work with technologies that work with nature. It's as simple as that. It's protracted observation of nature. One of my favorite tools is on the project. Bill Mollison from Australia being the driest continent on the planet, observed nature for 20 years and came up with an entire system to work with the planet. And the technologies that we've been exposed to and have been fortunate to work with are based on the nature, are based on nature rather than against it. They work on gravity, use zero chemicals, no energy. And it's absolutely possible, and it's out there. Every solution is out there. So this solution, it's a point source solution. It purifies air, there's clean water storage. There's no urban flooding, reduces everyone, etc. Just the opposite. Same thing. As I was talking about the fundamental design problem, that actually stems from the ancient world. We just keep following it. We keep creating a society around it, creating our roads and our urban infrastructure, which is impermeable. It does not emulate nature. Nature does not work like that. When we do that, we disrupt the hydrological cycle. When we disrupt the hydrological cycle, we disrupt the way life works. So by making surfaces permeable, we solve half the problem. And by then, restoring, collecting, by storing and collecting water, reusing it, just exactly how much it functions. This is a vision we want. We want to see our cities look like this. And if we create water sensitive cities, or just sensitive cities to the environment, we can. It's absolutely possible. So roughly, to define water sensitive urban design, a holistic approach to planning and design of urban care that aims to minimize negative impacts on the natural water cycle and protect the ecosystem. Now the various tools, I don't want to go into this example of information history. The various tools around it would be, some fit, some that are talking about water audits, then there's the water footprint assessment, there's the green, blue, grey water footprint depending on what is the rainwater volume. Why businesses will be interested in any of these tools, primarily. There are huge planning tools, there are cost savings involved, but our communities will be interested for the same reasons as well. You can, as I said, harvest and reuse that water as well, and efficiently use that water. And for large businesses, of course, as I said, another tool is watershed management, studying the relevant characteristics of watershed, so all life is sustained within that watershed. Watersheds, in fact, one of the biggest mismanaged areas of the sources of water is watersheds. This is a case study of a large public sector unit in Madhya Pradesh, where we conducted a micro watershed management study. They were able to harness maximum potentiality for available water resources by using the 3R concept that I was talking about. It was up to 15,000 cubic meters a day, and identification of water losses and leakages up to the tune of 4 lakh cubic meters per annum. Cost savings around 55 lakhs per annum. So it just dovetails into what Sanjay was talking about. There are really huge cost savings, huge water savings involved. It's tremendous planning tool. Any industry, any business, it's in their own self-interest to do this. May I request the gentleman to turn off the phone, please? Thank you. This is another sort of a recharge study that was done in Punjab and Andhra Pradesh for a large corporate. This is where a water neutral status was identified with the help of recharge structure, reduction of nearby ponds. The annual withdrawal that was going on was about 285,000 cubic meters, and a lot of that is unnecessary. At least that was identified. And then there were cost savings through using ETPS to be treated water, controlling evaporation losses, storing and reuse of rainwater. Water audits, I'm not going to go into, Sanjay's done a great job doing that. So I'm going to talk a bit about technologies. Technologies for creating water-sensitive cities. Clearly, rainwater harvesting, everyone knows what that is, just the purest form of water. However, there are many different ways we can do that. There are many conventional structures out there looking like this, schematic of that. Unless the people know what they're doing, our study indicates that 85 to 90% of rainwater harvesting structures in India, when they go past a year or even after the first rains, lie defunct. Because it's just, they're either choked up, clogged up, haven't been cleaned, the gravel hasn't been cleaned, there's a whole many things involved. So going back to what I was talking about, which is working with nature, using designs that work with nature, we identified modular systems. They have tremendous advantages over the traditional rainwater harvesting systems. They use capillary action, and there's through geotextiles and stuff, and then there's regular aeration of water. And the best part is every single module here is designed on a molecular level of water, molecular design of water. The water is, we commonly talk about water, but we forget it's actually H2O, and oxygen is an important, very important element. And the traditional solutions, if you create an RCC tank or the traditional pipes, what happens with the water is there's no oxygenation. And water, over time, loses its quality. So it requires that aeration, even if it's being stored for a long period of time. So it requires the nano movement as well. And these structures provide that, and they're highly load bearing, can be placed anywhere. Typical schematic, you can have a desilting chamber, an oil trap, a microfilter, and then it could be a percolation pit, it could be an infiltration, it could be store and reuse, a recharge, various flexible applications of it. These are some of the case studies of installations of the same. This is actually in Rajasthan. This was a very, very large campus of a company, and they lie in a critical zone. That means they have to recharge 160% of the water they use, the fresh water they use. In that case, they could not do it in their premises alone, so we did about 60 to 70% within the premises and did the rest outside by adopting a few villages, creating ponds, using this technology, using our modular modules, as well as this technology that you see. And these ponds were created and they brought life back around in the village. As you can see, the recharge wells were created around rather than the center of the pond to make sure that there's always some water there. I think my esteemed colleagues have already spoken about wastewater treatment. However, this technology that we're exposed to, again, sits well with us because it again uses no chemicals, no external energy, and is again gravity fed and is modular. Wherein the gills are themselves a high growth environment for bacteria and fungal biomass, so when the nutrients pass through the system, they just eat away at that and they keep multiplying. Then this bioremediation, I believe, I might have spoken about it, I was here for the morning session. Sanjay, is that true? Yeah, okay, good. So I'm not going to get into that. Then there's the ecological drains. This is using the same modules that we use for rainwater harvesting. We create a micro buffer between permeable and impermeable surfaces, as well as provide water for irrigation, for vegetation around in that area. So you would not need, those really tardy trucks around that are just going to go around, or water tankers around, just going to water the edges of the roads and stuff like that. So this kind of takes care of it, and of course this water can be channeled and collected and reused again. This is what it looks like in the installation process. One of my favorite technologies is an enhancement of these ecological drains, which is creating biospheres and rain gardens. Using the same water that we collected at the surface, we can create biospheres and rain gardens. Some of the installation pictures are the same as schematic. This is a case study as well doing the same. So as you can see on the top, there was a typical drain, and once we had the ecological channel wrapped around the geotextile, backfilled it, and it's highly load bearing, so you can just cover the entire surface, put the rain garden on top of it. Another one would be, as I was talking about earlier, creating permeable surfaces as opposed to impermeable surfaces. So these various pavers that we've been exposed to on our journey towards sustainability, these are permeable pavers. So you can have surfaces look like this, beautiful surfaces look like this, and yet there's no runoff. You can capture every drop of water that falls in them. Then there are these turf pavers as well, where you can grow grass as well on top. This is a typical laying out process design. Another technology that we work with is preventing water loss, water evaporation loss. India being a subtropical country, the amount of sun exposure is huge, and we lose a lot of water due to evaporation, especially for a state like Rajasthan. Mr. Chairman, do please keep me updated all the time. So this, using this silicon-based gel is 100% biodegradable, it's food grade. What it does is it prevents 50 to 60% of evaporation loss. It prevents that. This was our suggestion to one of the PSU that we actually worked with, and they're actually implementing this, which it is double whammy in the sense that this is solar power for generation as well as over a reservoir to prevent water loss evaporation. Drip irrigation has been covered, but it's certainly a very, very effective technology for creating water-sensitive cities as well. Then there are these, there's this urban heat island effect and things like that. We do need more vegetation, and I find this was amazing. A lot of people give credit to Patrick Bloch of France for it, but I find that the example came from Cuba. Cuba, which is south of America, is a small island country, and the United States imposed trade embargo on Cuba because it's a communist country and they were having some political issues. So for many years, it had trade embargoes and it could not import food. It was a net importer of food. It could not import food from a lot of countries. So they came up with very, very innovative ideas. Whatever urban land they had, be it on the terraces, along the walls, any urban space left unused, they would start growing food. And before you know it, that country became a net exporter of food. So this is totally possible. We just need to look around, just the buildings that we have, what we can do. We can create additional social spaces on the top by creating roof gardens. There's a lot of spaces that are lying unused. And again, we're not being water sensitive about that. So we find these vertical gardens, especially the modules, these kind of modules, they're very large pots. They help in the root growth of plants, all kinds of plants. You can grow vegetables like this as well, and this can be along any walls, and they retain water. And there's a drainage system below that, so there's water constantly recycled. You don't need additional water as well. So you can run nutrients and water through drip irrigation within the system constantly. So it's a highly, highly water-sensitive design. Urban spaces, domestic spaces, hotels, anywhere. This is what it looks like. And this is an example of the dealer in Shankipur in Delhi, where this has been implemented very successfully. We've got various examples like that. These are just for aesthetic purposes, but as I said, this can be used for functional purposes as well. Then there are these the roof gardens. Now we use drainage cells, as you would see right in the middle. That again is every time we apply water to a roof garden, the drainage cells, what they do is they retain some water and they channel the rest of it. So again, you don't need to constantly water it. So once you water it, perhaps you don't even need to water it for the next 2 weeks or something like that, because there are cups that retain the water for a long time. They're below the surface, so they're not affected by evaporation. And also this kind of setup, what it does is it does not require additional load-bearing capacity on a building. So even a heritage building, existing building, can be taken care of. And besides that water part, then it reduces the ambient air temperature around the place, creates biodiversity, attracts some kind of birds, etc. So it's multiple effects. By the way, that is what good design is. You address one element and the rest, everything else is addressed. Bad design is you address one element and the rest everything goes wrong. These are examples of this. This is in Sydney, Australia. We were actually instrumental in this as well, and we're fairly proud of that. This is a landmark project. This is what it looks like in one of the case studies near Delhi, actually. So the constraints and barriers of successful implementation of water-sensitive urban cities would be, yes, it says lack of awareness, involvement, time cost, etc., etc. For me, I would say it's just a mindset. It's a shift in mindset. The day the mindset shifts that no longer water is a commodity, water is like no longer can we live without it because we're actually hitting a resource wall. You cannot grow beyond a certain level if you hit a resource wall. So, we don't have a choice. So it's simply the mindset. Once we change the mindset, it's a flow. It'll happen. As I said, the technology, the solutions are out there. I'd like to end with a little short video which encapsulates and summarizes the tools and technologies that I was talking about.